Every single time you send an email, watch a video, or just click a link, you're tapping into the internet's giant global postal service. And the key to that whole system? It's something called IP addressing. Today, we're going to break down exactly how it all works. Ever stop and think about that? You type a website into your browser, and boom, in seconds, the right page just shows up. That's not magic. It's actually a super organized, incredibly fast delivery system. And the secret sauce to that entire system is a unique address that's given to every single device online. We're talking everything from your laptop and your phone to the massive servers that host your favorite websites. An IP address is basically a street address for your device on the internet. Without it, all the data that makes up websites and emails would be like letters with no destination address, just totally lost in the mail. This unique number is what lets any two devices find each other and talk, all across the world. All right, so let's get into the nitty-gritty and break down the most common type of address you've probably seen. It's called IPv4, and for decades, it's been the absolute backbone of the internet. Yeah, I bet this looks pretty familiar, right? This classic four-part number is a perfect example of an IPv4 address. You might have seen one just like it when you were digging around in your home Wi-Fi settings. So the V4 part just means version 4, but the really key detail here is 32-bit. That little technical spec is what decides the total number of unique addresses the system can even create. And that number is just a little under 4.3 billion. Now, back in the 80s, when this was all designed, that seemed like a practically infinite number of addresses. But as we all know, the internet exploded, and that once massive number pretty quickly turned into a major, major problem. So check this out. Every single IPv4 address is actually telling you two things at once. The first part is the network address. Just think of that as the name of the street. The second part is the host address, which is the specific house number for an individual device on that street. This is what lets routers first find the right digital neighborhood and then deliver the data to the exact right house. Okay, but wait. How does a device know where the street name ends and the house number begins in that long string of numbers? Good question. Turns out there's a special tool designed for exactly that. And that tool is called a subnet mask. It's really the unsung hero of networking that brings order to all the chaos by drawing these really clear boundaries. A subnet mask works hand in hand with an IP address. Its one and only job is to tell a computer, hey, this part of the address is your network, and this other part is for all the individual devices. It basically defines how big your local digital neighborhood is. Now, to really see how this works, we have to look under the hood at how computers think, which is in binary with just ones and zeros. See, the subnet mask is just another string of binary numbers. It uses all those ones to mask or lock in the network part of the IP address. Then all the remaining zeros in the mask leave the rest of the address wide open to be assigned to individual devices. Simple as that. All right, let's switch gears a little because there's another crucial distinction here. The address your devices use inside your home is totally different from the one the rest of the world sees. So your home router creates its own private, little local network. It hands out private IP addresses to your phone, your laptop, your smart TV. Think of these like apartment numbers, right? Lots of different buildings can have an apartment 101, and there's no conflict. But to the rest of the internet, your entire home is represented by a single, globally unique public IP address, which is assigned by your internet service provider. That's the main street address for the whole building. So you can probably see where this is going, right? With only 4.3 billion IPv4 addresses and a planet full of billions of people with multiple devices, well, we ran out. The solution? A whole new version of the Internet Protocol. The timeline here really tells the whole story. What seemed like an endless supply of addresses in the 80s became super scarce once personal computers and the Internet really took off in the 90s. And that scarcity is exactly what drove the creation and adoption of IPv6, which was designed from the ground up for future growth. And when I say future growth, the scale is, well, it's almost impossible to imagine. This chart tries to put it into perspective. We went from 4.3 billion addresses with IPv4 to 340 times undecillion with IPv6. That's a 340 with 36 zeros after it. It's a number so huge, someone calculated that we could give an IP address to every single atom on the surface of the Earth and still have enough left over to do that to 100 more Earths. Just, wow. Yeah, as you can see, an IPv6 address looks totally different. It's a whole different beast. It's way longer, and instead of just numbers, it uses hexadecimal characters. That's numbers 0 through 9 plus the letters A through F. And you'll notice it's separated by colons now, not periods. The changes go way beyond just how long the address is. IPv6 uses a 128-bit system, and that's what creates that insane number of addresses. But the designers also used it as a chance to make improvements. The header, which is kind of like the routing info on an envelope, was streamlined to be simpler and more efficient for routers to handle. That means better performance. Even little things got updated, like renaming the time to live field to hop limit. Phew! Okay, we've covered a ton of ground here. We've gone from the basic building blocks of IPv4 all the way to the vast, wide-open future of IPv6. So let's bring it all home and recap why your IP address is so important. So what are the big takeaways? First, at the end of the day, every single device online needs an IP address to talk to anything else. Second, the old IPv4 system just plain ran out of room. Third, subnet masks are what create order by defining those network neighborhoods. Fourth, there's that crucial difference between your private, local IPs and your one public IP that the rest of the world sees. And finally, IPv6 is the solution that gives the internet basically infinite room to grow, forever. And that leaves us with this one kind of amazing final thought. For the first time, really, the growth of the internet isn't limited by a lack of addresses. With this virtually infinite digital space, the potential for new devices, new connections, and totally new kinds of apps is just limitless. So the only real question left is, what are we going to build next?